Okay, hello everybody. I'm in my little shop here, and I'm working on a small router, CNC router, actually. I've been working with and on these things for probably 10 years. If you can see my computer, this is actually Linux CNC. I'm having some difficulty with how I'm just setting this thing up to do a recap. What you see me leaning on here, this is a Harbor Freight mini mill that I've converted over to CNC. Works great. This thing, it was one of those small Arduino controlled CNC routers off of Amazon, eBay. You can get them for little or nothing. But I wasn't able to get the controls to work the way I wanted them to, including having bought a new control board and installing it. I've got the new control board put away somewhere up in the shelves. Anyway, my background is the controller. It's an ancient controller now. Most people that use Linux CNC use one of the USB controllers, controller boards, or there's some manufacturers that sell the board along with a kit that they manufacture for different applications. I learned the Linux CNC probably 10 years ago and figured out, keep in mind that my background is machining and industrial maintenance. So my background is actually perfect for learning and figuring out how to repair and fix a lot of these things, whatever. So anyway, I know very well how to implement the TB6560 control board from a parallel port of the computers using the Linux CNC operating system / controller. So that's what I've done to this thing, is, which you can't see it. Here's the parallel connector from the computer, and that control board is back here. Now, I have been able to actually get the movement on the machine, but which is the first thing. Next step being get everything configured in the software to calibrate the movement, making sure 1 inch is 1 inch. Anyway, where I'm at right now is, it seems that the motors are, they're not binding up, but the parities and the steppers. Any of you that are familiar with the Linux CNC or the open, what is it? The like software. There is some variations that are closed because they're produced by actual companies. Anyway, the steppers and the settings, I'm wondering if the settings is off and if that's causing the movements to be jerky. They're very jerky. And as a background, I have done 2 CNC routers. One of them was 5 foot by 5 foot, which gave me a working surface of 48 inches. That's one of them. And all of most everything that I've done like this has been Linux CNC controlled. Once again, staying consistent, being able to do these. Anyway, to the point that these movements are jerky. And I just did actually a rebuild on this. It was garbage picked, and I've probably got $40 in rods, things that it was missing. So I have it working okay mechanically. And for any of you that are knowledgeable, primarily the issue that I'm describing is going to indicate that there's bind up somewhere in my guides or my gearing or something like that. And that's actually not happening. I know it's not. The reason I can say that, with all the electricity turned off, everything runs by hand smooth. You know, I can turn each thing. Man, it's just like perfect. Anyway, I've had some movement control issues with other things in the past, and it was all in the settings, and that's kind of what I'm thinking here, that it'll be the settings. I just moved to this location a couple of years ago, and when I did, I had to take all of my shop, everything down, and store it, move to the next county, set up my shed, and then go get all my parts and everything and put it back together. And this mill back here, yeah, I had messed up with, I hadn't really logged what wires were where and whatever, so I was really kind of having to do a complete new install, basically. And I did have similar issues to what I'm facing with this one, with that. It took me probably a week to get it all figured out, but it's running great. Anyway, back to this. I've got, if you can see it, here's the software here on the screen. I'm expanding it, and for those that know Linux CNC, the physical buttons and things that you would have on a industrial CNC mill or lathe or something are the same buttons are here on the software. So it has the emergency stop button and the power button and all that. Mostly representative, but certainly functional. You have to function these items in order to make it work. So that's what I'm going to do now is right here. Can you see that? Nah, hell, you can't see that. You might. Anyway, my cursor, here's the power button, and then here's the emergency turn off. Now I'm homing the 3 axis to their current point of origin just to get it running, and let's see what we got. So now I'm going to, I don't know if you can see this, the way this thing works with the older parallel port controlling. I actually don't know nothing about those mega boards and all that, all them other USB, they're USB type boards, ports, controllers. I have never used those. I have no idea, and frankly, I don't care, because this works good. What I have learned in my machining background, man, we used machines that was 20, 30 years old, but they worked. So there was no need to upgrade to the newest, latest item, because it worked. And that's all you need, is for the machine to do its job, get the part made, and get it out the door. And that's basically what I'm doing here, is that I'm just trying to get this thing to work. After all that long spiel, with the keyboard, I control the motion to test what's going on with this thing. Let's see what we got. Okay, those are wow. Those are way off, because the rapid travel is only running at 3 inches. And this is going to be fun. I have different instances of the controlling software running on this computer. Let me explain. I have two or three. I have 3 machines here right now, and at any given time, I'll be running the mill, and you can configure Linux CNC and name that particular setup. This is my mill. That's what I have it located in the computer for. This mill is my mill. Anyway, I'm gonna take this one down and pop in another one, or bring up another one, and I'm not sure about the overrides, the way you configure this. I have to go back to my books or my paperwork to reconfigure this. And the last time that I used this, any of this, was in the fall, some months ago. Been too cold out here to worry about, and I ain't been worrying about heating it. Heck with it. Anyway, and for the record, it is middle of March, so I'm just now getting started. Let me kill this particular one and bring up another one to be able to do what I need to do. Okay, here we go. Coming up. Boom. Okay, turn it on. The safety button. Home X, Y, Z homes. Now try to move it. Okay, again. Huh. Okay, okay. As I recall, this particular one, and it's coming back to me now after the winter. This particular one, I had something wrong with the configuration, and it's down in the INI file and the HAL. Those of you that know Linux will come closer to understanding. Those that are really deep into Linux CNC, you should actually understand. There's INI files, and there's a HAL file. I think 2 of them. There's about 6 or 8 files that you have to tweak sometimes to get what you needed done. Anyway, I'm going to kill this one, and let's go on to the next. Okay, we did that one, and this one. This is one that I've got labeled in here called test router. Let's see what this one is. Let's see what it does. Let's see. Power, emergency, home, X, Y home, Z home. Let's see what we get. Well, now that sounds real nice. It don't sound at all like the one it did the other day. No, that's beautiful. That's almost as beautiful as you. That's beautiful. I like that. So I can demonstrate the problem that I was seeing yesterday, which prompted me to want to come in here today and make a video on correcting this issue. Let me bring up that iteration and show you. Let me get this one labeled down. This is test router. Okay. I'm going to write that down so that I do remember. And I've got about a half dozen of them in here configured. Test router. Okay, now, back to what I was demonstrating about earlier. I think this is the one that I used to duplicate the screwiness. No, that ain't it. I have kind of a failing memory, and it does come to me now. I did, in fact, the TD6560 bolt controller boards has got the little dip switches that sets your I forget what that's called. My memory's kind of fleeting. Anyway, those dip switches are set to have an 8, a quarter, a half, and a full number. And I think what that's doing is that's establishing how much current is applied to the motors. And these are also, you'd have to know CNC in order to get this. But as parts are being ran, as those motors are being ran, as it's going from one direction to the other direction, the one direction it gets stopped, it gets current applied to that motor, and it's a hold. That's what I think they call it, the hold pressure. And that's applied by the current from the controller. And that's what those dip switches do. Those dip switches, the amount of electricity that it uses makes a difference on a couple of things, 3 things, whatever. But that holding pressure that motor is doing, that motor is stopped. And when a cutter goes around a corner and so it can head back in the other direction or does a reverse, that motor is holding so that the part's not moving in this direction at all. That's the theory behind it. And it is those dip switches that they influence the speed of the motor. They influence the current being applied to the motor, which controls how much horsepower it's got, basically. So, getting back to this, yesterday before I retired, I did in fact flip those switches on those controllers as a test. I didn't even have the computer. I didn't have nothing turned on. You get a chart with these particular controllers with these dip switches, and I didn't have one for this particular controller. I looked it up on Google. Google is our friend. Anyway, I had looked it up on Google a couple of weeks ago, and I never could really get a PDF or a manual or anything on this particular board because I had gotten it cut right. I think this board probably predates the controlling board that I'm using for this other machine by 3 or 4 years, which means that this is a copy of some of the first boards that came out, and it's only actually 3-axis. These particular boards that you see now, the 6560, most of those controlling systems, for any of you investigating or any of you that already know or somebody that's getting ready to set one up, it's actually probably simpler to use those USB controlling boards from the bigger manufacturers. And there's 3 or 4 of them that are name brands, and I forget those name brands. But anyway, to the point, those are probably easier. But these are the ones that I understand better. But this particular board, almost all of this class 6560, TD 6560, is most of them manufactured now. These boards are separate. So when you have to set up something like this, you've got to make allowances for the main interpreting board, and then a daughter board for each particular axis that you're wiring in. And those daughter boards wire into the main board, and I think most of those are set up for 4-axis also. I know this one is, this board, because I don't use it. This particular one that I've installed in here, I had it in stock for a long time. And it's 3-axis. Additional information for you, these controller boards, I think I might have one laying here handy. Oh, it was laying here. I had a dead one here somewhere. I'd like to get it, show it to you real quick, but it looks like I don't have it laying here right handy. Okay, anyway, these particular boards, these are all encompassed. All the components for all of it is on that one board. And I like those better. Well, the ones that are pieced out, if you blow a particular function, you can just buy that one board and replace it. Hence, the board that I've got floating around here that I can't find at the moment. I blew one of the controller IC chips on one of the axes. The other three worked fine, but it wasn't worth a spit. One axis just sat there, huh? So anyway, I pulled this one out of stock and installed it. It is a 3-axis board, and it has those dip switches I was telling you, and I flipped those yesterday, and it looks like, having done that, I'm sorry, getting back to it. I had information on those dip switches for the other boards, the 4-axis boards. This one, the dip switches, the 4-axis board uses 6 position dip switches, and it gives you all of the information for those dip switches, what you're wanting to configure for it. This one uses, on one end of the board is a 4-position dip switches, and on the other end is 2-position dip switches. And since I didn't have the actual literature for this board, I couldn't actually go in and say, okay, this switch is doing this, and this switch, because you got to turn on 1 and 4 and leave 2 and 3 turned off in order to generate 75% current for that motor. And then those other two position switches on the other end, I forget what it is that they do. Anyway, it doesn't really matter. The only thing that matters is success. And I took a wild guess last night before I went to bed, and it looks like I might actually have this thing actually working the way it should. It was, oh man, it was bad. And it looked like it was binding up. It was bad. Let me go back to here. There. Okay. Okay, that one is the one that didn't work. That one is my mill, May 24. Small router. Boom, 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 boom. No, the jog speed's too low on that one. So that's that one and that one. Router test. Okay, yeah, this is the one that I found to be successful. Okay, turn up the jog speed a little bit. Okay. Turn it up further. Yep. Can you hear that? That's actually smooth compared to a lot of your homemade or home operated CNC routers. CNC machine mills, routers, or layers. But it seems like I've actually got smooth action. Man, I'm telling you, I thought I was going to have to buy new motors to match this particular controller. But this is the motors that came with this machine. They seem to be working okay. So I'm going to call this a success. And I'm going to stop this here. And I'm going to invite you to come back, watch me kick the tires. I'm going to ask you to subscribe, give me a like. I'm trying to accomplish something here, and I would appreciate it from you if you would help me. And you can do that by liking, subscribing, and pass me on. If you meet somebody else, or you're emailing with somebody that you've met through one of the Facebook groups or through some other way that is where you're not really, you know each other through the net, but somebody that this information might, sharing this information might be a tidbit of the little bit of help that they might could use, please do me a favor and pass me on to them. It would be very much appreciated. And I hope you have a great day. God bless you.